Welcome to another online video. Today's lesson is going to deal with surface area of triangular prisms. Fill out your table of contents. Page 99 is where my table of contents is. Label it surface area of triangular prisms. On the cover, you see 3 different nets of triangular prisms, and we did some of this work in class today. All triangular prisms will have 3 rectangles and 2 triangles that make up their net. The first one that you see is when you have a equilateral triangle. And the reason why there's 3 different kinds is that there are 3 different kinds of triangles. So this is one example of what a net would be. So what I'd like you to do, you're going to need at least 4 different colors today. So make sure you have some crayons and color pencils available. So these 2 triangles are going to have the same area. Also, because it's equilateral, these 3 rectangles will also be the same dimension. So I'm going to shade them in the same color. What's different about the one over to your right on your note sheet is that the triangles are isosceles. You know that they're isosceles because of this hash mark. These 2 sides are the same, and these are going to be the same area. Always, the triangles will always be the same area, but the rectangles, you'll have 2 of them that are the same. So these ones on the ends are going to be the same dimensions, and then there's going to be 1 rectangle that's going to be either bigger or smaller than the other 2. So go ahead and shade those triangle, the 2 rectangles that are the same, and then the one that's different. The third kind of net you'll see is when all sides are different of that triangle. It often resembles what I like to say is the airplane net. Here, you're still going to have the 2 triangles that are exactly the same. I'm going to shade those in the same color. And for this one, all 3 rectangles are going to be different dimensions because the triangle has 3 different side lengths. So I'm going to shade each rectangle a different color. So luckily, the directions of how to find surface area does not change from rectangular to triangular. You're still going to need to find the area of each of the faces. Remember, there's going to be 5 faces instead of 6. Rectangular prisms always had 6 faces, top, bottom, side, side, front, back. However, rectangular prisms will always have 2 triangles and 3 rectangles. So there's the 5 faces, and we will just be charting them. After we do that, we're going to add up all of the areas. There is no formula for this because the triangular prisms can vary so much. It's best to just chart it out. You can use the 3-dimensional picture or the actual net. So I'm going to do one drawing the net one and then show you how to use the 3-dimensional model or picture. Just a quick note on this chart before we go inside. I just gave you a sample of what you could call the rectangles. Sometimes, depending on how the shape is positioned, you're going to maybe have a triangle on the bottom, so you wouldn't want to call it the bottom rectangle. So these 3 different kinds of rectangles can vary a little bit. You are always going to have 2 triangles, of course. So I'm going to start on the inside. I'm going to do the 3 that are on the left, and then you're going to try the 2 that are on the right. So for the first one, I'm actually going to draw a net to help me solve, and then for the other 2, I'll just show you how to use colors and chart it out. So I'm going to do the chart and the net for this one. What I'm noticing right away is that the 6s are on each side of this triangle, making it an equilateral triangle. And so I know that the rectangle faces are all going to be the same. I'm going to draw 3 rectangles to represent that part of the net. They're going to be pretty close to being squares. Now I'm going to attach my equilateral triangles to this, and I'm going to just put them in the center. Now we have to add our dimensions. We know that the base of the triangle is 6. Here, I'm going to be paying attention to this right angle symbol, and it is going to reference how tall this triangle is, and that I have to label as 5.2 centimeters. This is the 6 centimeters, and then the other dimension that I need is that 7. This will help me make my chart. I'm also going to show you how to color this to help you see it while we're charting. So the chart is going to just have 2 columns. I'm going to deal with the area, and my faces are going to be the first triangle and the second triangle. So we're going to deal with the triangles first. When we are using our 3-dimensional picture and not our net, we can use some colors, and I'm going to color in the triangle piece very light color to start. This is the triangle that I'm looking at because it has the dimension of that height on it of 5.2, and I know that all of my sides and my base right here is going to be 6. So my first triangle and my second triangle are going to be that pink area, and that's going to be 1/2 times 6 times the height, which is 5.2. It's going to be the same for the second one. And then I actually need to find out what is that area. When we use our calculator, we get an area of 15.6 for both triangles. Now let's deal with the bottom. Bottom rectangle, I'm going to do another lighter color, my green, and that is this rectangle right here. Looks like a parallelogram, but that's just because it's a 3-dimensional picture written on a flat piece of paper. But it's one of these rectangles. And remember, they're going to be exactly the same. And this rectangle is 6. I like this part. 6 is one side of this rectangle on the bottom, and this line and this line, which is the same as this line, is going to be 7. So all of these dotted lines are the same length. So my dimensions are going to be 6 times 7, which is 42. The fun part about this one is that the right-hand side of this shape is this parallelogram right here. I'm going to shade that in blue. It's still going to be the same dimensions as the bottom because it's an equilateral triangle that we're dealing with here. So the right rectangle and the left rectangle are going to have the same dimensions. So we're going to end up with another 42 for both of those. So let me show you where that final rectangle is. It's the one that is on top of the other one. So that's why I saved my darker color for last. And I know it looks messy, but this purple is going to be the one that is covering the other. Remember, this is kind of a see-through shape. So you have 2 triangles, and then you have a rectangle that's on the kind of towards the left and towards the right. This is how we're looking at this. So these 2 rectangles are on the left and right side of the tent-looking shape, and that's how we're referring to them. The right one was blue, and the left one I have as purple. At the end of this coloring, all we have to do is add up 42, 42, 42, 15.6, and 15.6. Be careful when you're putting these numbers into the calculator. You don't want to miscalculate by punching in a wrong number, so do it a couple times to make sure you're correct. I get 157.2 because it is in centimeters, and because it's area, we're going to have a centimeters squared for our unit. So this one, we're going to just deal with this 3-dimensional shape, and we're going to color in the different pieces while we're charting the areas of each face. So get your chart ready with the face and then the area. I'm going to start with my first triangle, which is going to be the same dimensions and area as my second triangle. Again, I'm going to start with a lighter color so that I can keep layering the colors on top of each other and be able to see what I'm talking about. So my pink triangle is going to be paying attention to these 2 parts of the triangle, so I'm gonna need this dimension and this dimension for my height and my base. So my area formula is half times 8 times 15 for both of my triangles. Half of 8 is 4, 4 times 15 is 60. Now I'm gonna move on to my bottom rectangle. That is going to be this parallelogram looking rectangle. It's really a rectangle even though it looks like a parallelogram. And now I need the dimensions of this guy. I'm going to highlight it in black so you can see. This part of the rectangle is going to be 20. And this dotted line also is the same as this one, which is our 15. So our bottom is going to be 15 times 20, which ends up being 300. Now I'm going to pick up a slightly darker color for the left-hand side. I'm going to do the left-hand side first, and then I'm going to come and do this right-hand side, which is a bigger space on top of the other. So this is going to be my brown, and it's referring to the left-hand side. Go over on top of my triangle. And now I'm going to be looking at this part of this rectangle, which is 8, and then this guy. So the diagonal line that's going up to the right is the same as this, which is the same as this. Notice all of these lines that I'm highlighting in brown are parallel. So this goes up to the right, this goes up to the right, and this goes up to the right. So I'm going to need my 20 for the rectangle on the left-hand side. That's going to be 160. And one more left, the one on the right-hand side. I get my dark blue for this one. And that's going to be this big parallelogram that's sitting on top of all of the others. It's going to be kind of a mess color-wise, but shade that big. This whole thing is laying on top. It's like the ramp that you would slide down. So now what are the dimensions of this? We have this guy right here. I'm going to use black to kind of have it pop out for you. We have this part, which is this 17, and we have this side, which is the 20 again. Now our final dimensions, we're going to have 17 times 20. Multiply that, it ends up being 340. Now we just have to add up these numbers to get our surface area. When we add it up, it ends up being 940. We're dealing with meters, so our unit is meters squared. One more for me to do, and then 2 for you to practice. I saved this last one for third on purpose because this is one where it's actually a triangular prism with the triangles on the top and bottom, not flipped on its side. So we're going to call our faces a little bit different, and this one is also an isosceles triangle. So we're going to start with the first and second triangle. We could call them the top and bottom triangles. That would be fine as well. And let's look at the dimensions of those triangles. I'm looking at my right angle symbol. My right angle symbol touches this 7 and touches this dotted line, which is 12. So the 7 and the 12 is what I need for my triangles. So 1/2 times 12 times 7. Same thing for the bottom. Half of 12 is 6. 6 times 7 is 42. So my triangles are going to be 42 inches squared each. Now I'm noticing that these two parts, it's almost like a pizza box. These two rectangles right here is the front. And it's going to have a dimensions, I'm going to call it the front rectangle, of 12.5 and 1, which is just 12.5. The cool thing though is that this is an isosceles triangle, so this one that's in the front is going to be the same exact one back here. So if you see that there's another similar rectangle, and I'm going to shade in red. This is going to be the same dimensions because we have a 12.5 pointing to this line, and all of my vertical lines, this one, and this one, are all 1. So I'm going to call this the left rectangle, and it's going to be the same dimensions as the front one. I have one rectangle left. It's the end of the pizza where the crust would be, and that's going to be on the right-hand side. And we have our dimension, again, our vertical line is 1, and then we have our 7 going this way. So this is our final rectangle, again, pay attention to. Call it the one that's on the right-hand side, and that's going to be dimension of 7 and 1, which is 7. We have our 5 numbers. Now all we have to do is add them up. When we add them up, it ends up being 116 inches squared. So I want you to try the 2 on the right-hand side. I'm going to have a picture of what your answer should be when you're done. Here's the answer to the first one you needed to try on your own. I used pink to represent the triangle with 5 and 2 being its dimensions. The green for me is the bottom. The right-hand side is that red, and my blue is on top over on the left. Those are the dimensions. Hopefully you got the same thing. Now try the next one right below. For the last one, I used the same color scheme. So I have my pink talking about the base and height of my triangle. This one was a little tricky because it needed to be 5.7, not 7. So be careful you're using the right angle symbol to tell which sides of the triangle you need. So we have those dimensions there. My green rectangle is the bottom, so that's 4 and 8.6. My red is the right-hand side, which is 8.6 and 7. Notice this is parallel to this, which is parallel to this. And then my blue one crosses over all of them, and that's the 5.7 and the 8.6. When you do the math and add it up, you should have gotten 166 and 42 hundredths meters squared for your answer. This is tricky. You have to be very visually attuned to what you're looking at, and that's why the colors help. Look forward to trying this with you tomorrow. Have a great rest of your day. Bye.